In this video, we will be discussing the Earth systems, the different types of systems, and how they interact with each other. There are four major categories when we're looking at different systems on the planet. You have the atmosphere, biosphere, hydrosphere, and geosphere. You could add a fifth one, which would be called the anthrosphere, and this includes humans and human development. But for today's topic, we'll just look at these four. Let's first look at the atmosphere. We'll be looking just briefly at the different components and the makeup of the atmosphere, and we'll get into this later on within the school year. But the atmosphere is made up of many different layers, and these layers are broken down based on density, characteristics, how they interact with each other, and temperature. The major zones of the atmosphere are the troposphere, stratosphere, mesosphere, and thermosphere. So looking from the surface of the Earth up, troposphere would be the first, then the stratosphere would be second, the mesosphere, and then the outer layer of the atmosphere would be the thermosphere. Each layer is broken down or separated by these pauses, if you will, where you have transitions in temperature, you have transitions in conversions of temperature, altitude, and those types of things. And these pauses, you have the tropopause, which is going to separate the troposphere and stratosphere. The stratopause separates the stratosphere from the mesosphere. Then the mesopause, where your last conversion is going to occur, separating the mesosphere from the thermosphere. From ground up, the atmosphere is about 348 miles thick. And the higher up you go, the less dense the atmosphere becomes, the more dispersed the particles of the atmosphere become, and obviously the cooler the atmosphere becomes. The components of the atmosphere, you're looking at the majority, roughly 79% of the atmosphere is made of nitrogen. 20% of it you're looking at oxygen, and then a small, less than 1%, is going to be made up of other types like argon and neon that wind out the parts of the components of the atmosphere. The next system, the biosphere, this is part of the planet where all life can exist. It's going to contain all of the organic matter being matter that is once living or produced from living things. The biosphere stretches roughly from just below the Earth's surface, getting into the crust where you have your bacteria, up into the lower parts of the troposphere. Now we know how life on the Earth works. It is driven by energy from the sun transferred through photosynthesis through the food chain, and that's how the biosphere is propelled. Is through this energy transfer, starting with photosynthesis, and then through these food chains and food webs. The next system, the hydrosphere. The hydrosphere is going to contain both, or all three stages of water. You're looking at water vapor, the liquid water, and even frozen water. This includes water in the ocean, salt water. You're looking at fresh water from lakes and rivers, and even the frozen water trapped in icebergs and ice caps. There's even going to be fresh water that we call surface water that you can find in the groundwater areas of the soil and the surface that comes from wells, water tables, those types of things. Now when you're looking at the supply of water on the planet, only 3% of the water found on the planet is going to be fresh, and that's looking at all the rivers and streams and lakes, the water vapor, especially when it falls as rain. They're looking at only about 3% of that water. The most of the fresh water on the planet, about 70% of it is going to be in our glaciers and ice caps. So roughly 97% of the water on the planet is not fresh water. It's going to be in the form of salt water or water that contains other chemicals or minerals. Of that 3% of fresh water, only about 1% of it is going to be usable or drinkable by humans. The next zone, or the next sphere we're going to look at, is the geosphere. This is the solid lithosphere land portion of the planet. This includes our continents, our ocean crust, our continental crust, the different plates that make up the crust of the planet or the crust of the Earth. Most of the Earth's surface, most of the crust, is going to be composed of elements like oxygen and silicon, magnesium. That is the largest part of the geosphere is going to be composed of these. Now, when you're looking at the geosphere of the Earth, most of it is not static, which means it's unchanging. Only the crust is going to be something that is constantly in motion. And later on in the next unit, we're going to be looking at these different plates, these different continental and oceanic plates, and how they interact with each other to form fault lines, volcanoes, mountain ranges, those types of things. Now, this study of the Earth system, it's a fairly new science. But the study of it is actually looking at how these major systems interact with each other. Some examples of system interactions with the geosphere, and you're looking at volcanism. This is where, as volcanism occurs, as these plates move and these volcanoes form, you can have the release of pressure and gases. A lot of sulfuric acid could be pumped up to the atmosphere during this time, and you get the interaction between the geosphere and the atmosphere as a result of this. This also can have an effect on the surrounding biosphere, or the plants and animals within this area. Another example would be how our atmosphere and hydrosphere are going to interact, and this is when we're looking at different types of storms that can develop, whether it be hurricanes, tornadoes, tropical storms, and this is all it deals with air pressure. It looks at warm, moist air, and how these air currents can carry warm, moist air over different areas, and these low pressure systems can form and high pressure systems can form, and this is how the atmosphere and the hydrosphere are going to interact. And then obviously once this comes in contact with the geosphere and biosphere, the resulting ends of those. Once again, another example, the geosphere. The geosphere, you're going to realize, is actually going to be an integral part in a lot of different types of interactions within these spheres. But when you're looking at earthquakes, you're looking at, once again, these crustal plates, the different types of plates, and how they move. There's always pressure being built up, and so when they move, that resulting release of pressure is a lot of times going to be felt in earthquakes. Sometimes earthquakes are going to be larger depending on the buildup of the movement of these plates. Sometimes it's not going to be as large, but this can definitely have an adverse interaction with the biosphere. It could also create fires, the release of materials through volcanoes forming or erupting through earthquakes, and that's going to interact with the atmosphere. They can also cause large tsunamis depending on where they're going to be located, how close they possibly are off land of islands and those types of things. Some of the larger eruptions, especially with volcanic eruptions that we've had in the past, have originally started with earthquakes, and the buildup of the pressure of these gases and the movement of the plates caused some of these more dormant volcanoes in the past to erupt, having some very, very large catastrophic events that could occur as a result of that.